Magandang buhay, grade 10 learners. Again, I'm Ma'am Marian B. Millanes talking about proving theorems related to chords, arcs, central angles, and inscribed angles. Still, the learning competency you need to achieve is to prove theorems related to chords, arcs, central angles, and inscribed angles. Let us now talk about the theorems related to inscribed angles and its intercepted arcs. This is the fourth theorem that we discuss for this week. If an angle is inscribed in a circle, the measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc, or the measure of the intercepted arc is twice the measure of the inscribed angle. Suppose we have here circle J. Based on the given, angle ARM is inscribed in circle J. Segment AR is A diameter. Let us prove that the measure of angle ARM is equal to 1/2 of the measure of arc AM. Let us prove the theorem using two-column proof. Number 1, we will start with the given. Angle ARM is inscribed in circle J, and segment AR is a diameter. So the reason is given. Let us connect point J and M. So we draw segment JM. At this point, the reason is 2 points determine exactly one line. When we have 2 points, we can connect them and form a line or a segment. After drawing segment JM, we have already triangle RJM. And also, segment JM is congruent to segment JR. For what reason? All radii of same circle are congruent. Number 4, angle ARM is congruent to angle JMR. According to the isosceles triangle theorem, if two sides of a triangle are congruent, then the angles opposite to these sides are also congruent. In third statement, segment JM is congruent to segment JR. Segment JM is opposite to angle ARM, and segment JR is also opposite to angle JMR. So since the two segments are congruent, then the two angles are also congruent. Again, our reason for that is the isosceles triangle theorem. As you can see in the figure, angle AJM is an exterior angle of triangle JRM. So, the measure of angle AJM is equal to the measure of angle ARM plus the measure of angle JMR. Because the measure of an exterior angle of a triangle is equal to the sum of the measure of its two remote interior angles. In statement number 4, angle ARM is congruent to angle JMR. Therefore, their measures are equal. So we will now substitute the value of the measure of angle ARM to the measure of angle JMR. That's why in number 6, the measure of angle AJM is equal to the measure of angle ARM plus the measure of angle ARM. This is equal to 2 measures of angle ARM. What property did we use? Yes, it is substitution property. Angle AJM intercepts arc AM. Therefore, the measure of angle AJM is equal to the measure of arc AM. What is the reason? The measure of a central angle equals the measure of its minor arc. In number 6's statement, the measure of angle AJM is equal to 2 measures of angle ARM. By substituting it on number 7, we can get statement number 8. 2 measures of angle ARM is equal to the measure of arc AM. The reason? Substitution property. Using number 8, by dividing both sides of the equation by 2, we can get the measure of angle ARM is equal to 1/2 the measures of arc AM. The reason for this is division property of equality. Now we have proved that the measure of angle ARM is equal to 1/2 of the measure of arc AM. It is indeed that the measure of an inscribed angle is equal to 1/2 of its intercepted arc. The fifth theorem is this: if an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. In this example, we have circle T. Given in circle T, angle KEA intercepts semicircle KLA. Prove that angle KEA is a right angle. In proving, we always start with our givens. So number 1, in circle T, angle KEA intercepts semicircle KLA. That is according to the statement given in your problem. Remember, angle KEA intercepts semicircle KLA. With that, our number 2 statement will be the measure of arc KLA is equal to 180 degrees because KLA is a semicircle. Our reason now is the degree measure of a semicircle is 180 degrees. The measure of angle AEK is equal to 1/2 of the measure of arc KLA. Since angle AEK is an inscribed angle, each measure is 1/2 of its intercepted arc, which is arc KLA. To explain this, we rely on theorem number 4, that the measure of an inscribed angle is 1/2 of its intercepted arc. Since the measure of arc KLA is equal to 180 degrees, we can substitute it now in number 4. The measure of angle AEK is equal to 1/2 of 180 degrees. As a result, the measure of angle AEK is equal to 90 degrees. We use substitution property. As a conclusion, angle AEK is a right angle. The reason for this is that we use the definition of a right angle. A right angle is an angle which measures exactly 90 degrees. Hanggang sa muli.